Welcome to the DIY Honda Garage channel. This presentation will provide a comprehensive troubleshooting guide for DTC P0563, which indicates an unexpected voltage in the PCM, Powertrain Control Module power source circuit. The Honda Civic model year range from 2016 to 2021 is under consideration, with this code being particularly important for vehicle diagnostics. Understanding the components involved, the nature of this fault code, and the systematic approach to diagnosing and resolving the issue is essential for effective vehicle maintenance. We will delve into the specific affected components, possible causes of the DTC, symptoms associated with the issue, and detailed troubleshooting steps to follow. This guide aims to assist technicians in diagnosing and repairing the problem efficiently. The PCM, or Powertrain Control Module, is integral to a vehicle's performance and operation. It manages engine operation, transmission, and other critical systems by processing input from various sensors. In this context, DTC P0563 points to an unexpected voltage level within the power source circuit for the PCM. This circuit's location is typically near the engine compartment, where the PCM is housed. If this circuit registers an unexpected voltage, it can lead to various performance issues, ranging from reduced engine efficiency to complete vehicle failure. Addressing this fault becomes crucial not only for maintaining optimal vehicle operation, but also to prevent further complications that could arise from ignored DTCs. Several potential causes can lead to the P0563 fault code. First, loose connections at the PCM can prevent adequate voltage flow, causing communication issues. Secondly, a faulty relay circuit board may not deliver the required power to the PCM, resulting in erratic voltage levels. Also, shorted wiring within the circuit could lead to a direct connection to ground or power, causing unexpected voltage readings. Furthermore, a damaged PCM itself can register this code if it is not able to process the supplied voltage correctly. Lastly, issues with the vehicle's battery, such as low charge or corrosion on terminals, could contribute to erratic voltage levels affecting the entire electrical system. Addressing these potential causes is critical in resolving the issue effectively. When DTC P0563 is present, several symptoms may manifest in the vehicle. Primarily, engine performance issues such as stalling or poor acceleration may occur due to the PCM not functioning correctly. Additionally, starting problems often arise, wherein the vehicle may struggle to crank or fail to start altogether. Drivers might also notice the battery warning light illuminating on the dashboard, signaling a potential electrical problem. Electrical system anomalies, such as flickering lights or erratic behavior of electronic components, may also indicate that the voltage supply to the PCM is unstable. It's also worth noting that the inability to replicate the fault during diagnostics could suggest intermittent issues related to a poor connection or a failing component, which can complicate troubleshooting efforts. The initial step in troubleshooting DTC P0563 involves verifying the problem correctly. Begin by turning the vehicle to the on mode without starting the engine. This allows any electronic systems to initialize and prepare for diagnostics. Utilize the HDS, or Honda Diagnostic System, to clear any stored DTCs associated with the PCM, ensuring that you're working from a clean slate. After clearing the codes, switch the vehicle to the off or lock mode and allow a brief waiting period of 10 seconds. This pause helps reset the vehicle's systems. Finally, return the vehicle to the on mode to check if the P0563 DTC reappears as either a pending or confirmed DTC, indicating if the problem has been reproduced for further diagnostics. In this step, you need to identify the potential area of failure. Start by turning the vehicle off to ensure all systems are inactive. Proceed to jump the SCS or Security Connector System line with the HDS to bypass security functions temporarily, waiting more than 1 minute for processes to stabilize. Next, disconnect PCM Connector A, which is a connector comprising 50 pins used for various signals and power. With the connector disconnected, measure the voltage between designated test points. Test point 1, found at PCM Connector A pin number 5, and test point 2, which is the body ground. This measurement is crucial. If battery voltage is present, it indicates a problem exists beyond the PCM. If no voltage is detected, follow the steps to check the integrity of the wiring. At this juncture, we focus on checking the integrity of the wiring leading to the relay circuit board. Disconnect the relay circuit board connector C, which consists of 18 pins. This will help isolate any issues caused by the relay itself. Once disconnected, check for continuity between the test points, PCM Connector A, pin number 5, and body ground. You must do this while the vehicle is still in the off or lock mode to ensure accurate readings. If continuity is confirmed, it indicates a short in the FI main RLY-CL wire between the PCM, specifically pin A5, and the relay circuit board. Repairing this short is essential to restore proper voltage flow. If continuity is absent, you can conclude that the wiring is intact, and you would move on to the next troubleshooting step. Troubleshooting now focuses on the relay circuit board, a crucial component that regulates power delivery. Start by removing the relay circuit board for inspection and testing. The testing process will help ascertain whether the relay circuit board is functioning correctly. If the relay is operational, you may need to delve into any authorized service information relevant to DTC P0563 or symptoms you have encountered. Sometimes, a PCM substitution may be necessary. If replacing it resolves the issue, the original PCM requires replacement. This thorough exploration allows you to confirm whether the initial problem resides within the relay circuit board or the PCM, ensuring efficient resolutions. In this 5th step, you will conduct another voltage measurement while further isolating the components involved. Disconnect the relay circuit board connector C, yet again, emphasizing the need for this connection to remain separate during testing. Measure the voltage at PCM Connector A, pin number 8, while using the body ground as a reference point. The vehicle should still be off to get an accurate reading. If battery voltage is present at this point, it signals a short to power within the FI main RLY outwire that lies between the PCM, specifically pin A8, and the relay circuit board. If no voltage is detected, the wiring remains intact, meaning diagnosing further in the next step is viable. The final troubleshooting step reiterates the necessity to ensure the relay circuit board is functioning optimally. After removing the relay circuit board, conduct testing to verify this. If testing confirms that the relay is working as required, explore any associated service information related to the DTC P0563, as there may be additional recommendations pertinent to your specific situation. Similar to previous steps, you may also contemplate substituting in a known good PCM. If replacing the PCM resolves the DTC P0563, it confirms the original PCM's failure. The focus of this step is to ensure all components are accounted for, allowing you to identify any responsible failures boldly. After completing the troubleshooting steps, it is essential to verify that all repairs have been made thoroughly. Begin by rechecking for any DTCs using the Honda Diagnostics system. This helps ensure that the P0563 code is no longer present. A comprehensive test drive is also critical. During this period, monitor the vehicle for any previously reported symptoms, ensuring they are no longer evident. Confirmation that all aspects are functioning appropriately provides peace of mind that the initial issue has been adequately resolved, safeguarding the vehicle's performance. Proper verification of repairs not only secures immediate results, but also enhances the longevity and reliability of the vehicle's systems. Prevention is key when it comes to maintaining vehicle integrity and avoiding future DTCs like P0563. Regular inspection of wiring, especially around the PCM and relay circuit board, will help identify wear and tear before it leads to costly repairs. Ensuring that all connectors are securely fastened prevents issues caused by poor communications within the electrical system. Routine checks of the PCM's functionality allow for proactive measures to be taken should any irregularities be detected. Additionally, monitoring the vehicle's entire electrical system assists in identifying problems early. If corrosion is found on battery terminals or electrical connectors, it's essential to address it promptly to avoid any future disruptions in voltage delivery to critical components. In conclusion, understanding DTC P0563 implications is crucial for maintaining vehicle integrity and performance. Following a systematic troubleshooting approach can accurately identify and rectify the underlying issues within the PCM power source circuit. It is equally important to verify that all repairs made are effective, which solidifies the resolution of the issue. Implementing preventive measures ensures early detection of potential problems, thus keeping your vehicle running smoothly. Ultimately, adhering to these recommendations fosters optimal vehicle performance while reducing the risk of unexpected failures in the future. Please like and subscribe to the channel. See you next time!